In this video, you will learn about increasing and decreasing functions. How do we use a derivative function to determine whether the function is an increasing or decreasing function, and a certain range of values of x. Okay, so you will need to recall all your differentiation techniques. You should have also already completed the SLS package on increasing and decreasing functions to get a good sense of what this chapter is about. Okay, so in this lesson, I will go through the lesson worksheet, and then we'll do some examples, and then you'll be asked to complete the last few questions as an in-class work, which I will then check. Okay, and the relief teacher will collect, and then I will check and go through in the following lesson. Okay, so first, you need to recall all these things about solving inequalities, solving quadratic inequalities, okay, which we have already revised as we are preparing for our WA1. So I will not be going in depth, okay, but I do want to help you recall that we went through this, right, where we have to solve a quadratic inequality, we will have to factorize first. F stands for factorize. Sketch, right? FS. And the last one, then you solve. So FSS. Okay, factorize, sketch, and solve. So don't forget the sketching part, which a lot of you tend to forget. Okay, so if you need to watch the video, you can go ahead and watch the video on how to solve quadratic inequality. If not, we will proceed on. Okay, so as you watched in the SLS video, when a function is known to be an increasing function if y increases when x increases. And a function is known to be a decreasing function when y decreases when x is increasing. Okay, so one example of what an increasing function is, it will look like that. Okay, increasing function. As x increases, y is increasing, right? So this is, this is your x. And this is your y. As you can see, when x increases, okay, x increases from left to right, y is also increasing. Okay, and then a decreasing function will look like this, something like that. Yeah. And then you have when x is increasing, your y is actually decreasing. Okay, so this will be known as a decreasing functions. Okay, and what do you notice about these two graphs, right? When a function is an increasing function, you notice that the gradient is always positive. Okay, whereas when it's a decreasing function, okay, the gradient of the graph at every point is always negative, going downwards, right? So that is the important concept that we need to highlight over here. Gradients of increasing functions are positive. That means the dy dx is actually greater than 0. Whereas the gradients of decreasing functions are negative and the dy dx is lesser than 0. Okay, so let's look at our first question and how we can apply that into solving questions. Okay, example 1, find the range of values of x for which the function fx is equals to this, 5 plus 12x minus 2x squared is increasing. Okay, so they are asking you to find the range of values of x. That means your answer will be in an inequality, right? And then the function is increasing. This means that the dy over dx is actually greater than 0. Okay, so how do we do that? We have to find out the derivative function first. Okay, so in this case, there's no y in this question. It is actually function of x. Okay, so actually it works the same way. Instead of writing dy dx, in this case, I can be writing, if I differentiate this, I can be writing f prime x. Okay, so if I differentiate this, it'll be f prime x, right? Or some of you all might be thinking, can I write it like that? B over dx f of x also can. Okay, they're all the same thing. Right, so I will differentiate this function. Differentiate constant 5 is 0. Differentiate 12x is 12. Differentiate negative 2x squared is negative 4x. Okay, so this will give us negative 4x plus 12. Okay, so now I want the dy dx to be greater than 0, as in derivative function to be greater than 0. So for fx to be increasing, f prime x has to be greater than 0. Right, so we're going to sub in f prime x greater than 0, and then we will just solve this inequality to give us negative 4x greater than negative 12. So x is this point when I divide by negative 4. Okay, I will have to flip the inequality sign. Okay, so just take note, then 12 divided by 4 gives me 3. So take note that this sign is flipped. Alright, so that's the answer. Okay, range of values of x, so it has to be an inequality. Okay, now we'll look at the next example. Find the range of values of x for which the function is decreasing. Okay, so I can give you a clue and then you can try this by yourself. So again, when you have the range of values of x, we are looking for a inequality. Your answer should be an inequality. Okay, for which the function is decreasing. So here is f prime of x is lesser than 0. Alright, so you try this question and then later on I will go through in the next video.